Hello, so we're back and this time we have a nice laptop to repair. Check here, HP, i7 Agent and NVIDIA graphics. This is a nice one. So what the customer is saying about this laptop is coming from a computer shop. HP Spectre 15-BL101NA. Client reports charging LED doesn't light up. Laptop doesn't charge and therefore laptop doesn't power on. Charger fine according to the voltmeter. So that's the problem with this laptop. I will say let's plug a charger and see what it's doing. Yeah, let's see what it's doing. So plug in the charger. The meter is coming on. 19 volts, so it does negotiate the voltage. We have 19, but it's taking like 20 milliamps. Very low current, very low current. Here is 5 volts, 160 milliamps. I will trust more this port. Yeah, this one. Let's see if it's sensing the power button. Where is the power button on this one? This one? This big button? Pressing the power? No. No, this is some volume thingy. Oh, here. Yeah, here is the power button on this side. So pressing the power button and nothing happened. You can see. You can see on the meter, nothing happened. I will say let's open the laptop and try to have a look inside. Yeah, the back cover is out. The battery is disconnected. This is some cover. Yeah, this hasn't been opened before. Yeah, no one opened this laptop. Good, and here, what do we have here? The RAM memory and stuff. Yeah, RAM memory. Good, let's take the multimeter and let's check the main power rail, yeah? Main power rail, good. 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 Main power rail is not shorted. Can you spot anything on the board? Coils, yeah? Coils. 150 ohms. This one is fine. This one probably is the charging coil. We have coils here. This one is fine. This one is fine. Okay, let's plug the USB port and check the main power rail. Now this one is 5 volts. $20. Okay, 19. But what is here then? What is here? We don't know. Okay, the main power rail is 19.8. 12.5. So everything is fine. Let's unplug the charger. Let's plug the battery and see if it's charging. Plug in the charger back. Let's see if it's charging. It's not charging. No charging are bad news. You know what I mean? So plus of the battery and we have 12.3 and it's not charging. That's bad. Let's see, this power supply, do we have voltage on it? 12.5. So the main power rail, which is 12.5 volts, is present. 3.3 on the EC chip. Okay, let's have a look. I think we have to go under the microscope. Okay, so we have a clear picture with the EC chip. Here we have 0. Here we have 0. Not sure where I should check here, but doesn't look good. I mean, I have a good news and a bad news. Not sure which you want to hear first. Okay, so the good news is, based on the current consumption, which is about 70 milliamps, it's nothing shorted. The bad news is we don't have 3.3 on the AC chip. So I don't think the AC chip is shorted, because if the AC chip will be shorted, I will see that current on the meter, yeah? But we have no current. Like 17 milliamps does not short. So where is the 3.3 volts power supply? We don't know. We have this little prick, and trust me, this is a prick, this chip. But it's working. The problem is this one, it is creating the main power rail, which is, let's see. So here we have 19. Then it's switching some MOSFETs. Yeah, probably those MOSFETs. Yeah, 4 MOSFETs here. And the coil output, no, it's not here. Where is the output? Yeah, here, 12.5, yeah? So 12.5 after those 2 MOSFETs. And the input is 19. So this chip is doing the job. But where is the 3.3 volts power supply? So on this point, I have no choice. I have to take the board out, and let's try to find a 3.3 volts power supply. We agree the problem is from the LDO voltage, which is not present on the EC chip. Also, just to be sure, we can check. Where we can check? On the power button. The power button is here, yeah? That means the 3.3 should be present on this cable. Nothing. So I have like 0 volts on every pin. Nothing. So the 3.3 volts is missing. Okay, let me take the board out. I have to take the battery out first. Okay, so the motherboard, it's out. And it's looking perfect. I mean, I can't see liquid damage here, so everything looks fine. Has a foil over. Finally. Yeah, let's see what we have on this side of the board. So on this side of the board, we have this chip. We have this chip, which we don't know what they are doing. This is the CPU driver. This one, check here. This is another prick. Yeah, this is the one. This is the LDO power supply. I think it's the LDO power supply. I'm assuming. What do we have here? More BIOS chips, more BIOS chips. TPS, but this one is good. Yeah, we have 2 TPS. Probably one TPS chip is dead because only one USB is working. Okay, let's go back to the EC chip. Yeah, it will be a little bit complicated to figure it out which one is the chip. But let's try to find a common point between those capacitors. And we can't find a common point. And that sucks. How we can find the 3.3 volts LDO? So we have plus plus. Yeah, that's 10 ohms. Lol, we have 10 ohms from here to here. Oh, that's sick. That's crazy. So you think we have a dead EC chip? Zero ohms. Yeah, okay. Okay, so we know this is the plus, yeah? Plus 3.3. Let's come with the power supply. 3 volts. Let me see what current I have here. 4 amps. Okay, that's too much. Good. Coming with the current here. No, here. Yeah, we have 2 volts. And the AC chip is not getting hot. Okay, that's interesting. So we no, it's not the AC chip. It's not the AC chip. One second. Let me grab the thermal camera. Those are good news. So we establish which is the 3.3 power rail. And the 3.3 power rail has like 10 ohms, right? Coming with a power supply, the AC chip is not getting hot, which is good news. But something, it is getting hot. Yeah, that current is not disappearing. Yeah, it's going somewhere. So where is going? It's going one to the AC chip, but that's fine. That's what I expect. And it's going somewhere else. What is this? What is this? Now you figure it out from where the LDO 3.3 is coming? From this little prick, which probably is burned, the TPS. Because that's why only one port is working. Yeah. This one is gone. 65982DA. Okay, what TPS we have here? 1 second. Let's see what do we have there. Is the same? Can we swap it? We have the same TPS. I can't believe. We have the same TPS. Now, I don't have the schematic. I don't know the schematic. So we can assume both chips are generating LDO voltage, but this being short, the voltage generated from this chip is getting shorter, is getting sent to ground by this chip. Or having two chips, but only one has LDO. Nah, it's impossible. Because if I'm using the USB-C with this, I mean, those are for 2 ports, so I should have the LDO voltage from both chips. So I believe we should remove this chip. This chip is gone. I'm gonna use some Sorin Rosin X-grade flux. Quickly, let's remove this chip. Let's remove it. So the 10 ohms, which we checked on the EC chip, is actually the internal resistance of this LDO power supply. Perfect, check that, the solder bores are perfect. We can solder this chip back. Okay, good, good. Perfect. So what about now? What about now is we are checking again. Let's see what current is taking there. Ground. It's taking nothing. Nothing. No current at all. You can see? Nothing. Ah, sorry. Ah, this was the multimeter. Okay, we have infinite resistance. You can see? Let me come with the power supply. Same. And it's taking 70 milliamps, which is perfectly normal. Yeah, 70. Those are good news. So, if we are plugging the charger, the board it will start. Let's see. So this port was good. No, it's not starting. But let's see the voltage. Do we have LDO 3.3? Let's see. So here we have, check on the screen, 3.2. You can see 3.3 volts. So we do have voltage. If we have voltage, can we start this board? That's a good question. That means we should have 3.3 on the power button, right? Yeah, I see the multimeter is restarting. Yeah, check on the screen, 3.2. You can see? We do have voltage on the power button. Yeah, just ignore the meter. Let's see if we fix it, huh? Okay, we need this ribbon cable, which is with the power button. Yeah. We need heatsink? No, we don't need heatsink. It's fine. So plug in the charger. Let's try to press the power on button. Pressing the power on button. And we have the white. I seen a light here. Yeah. You know what? I think this is the same. Let me connect the battery. I don't think this laptop it will start without the battery. So the battery is connected. Let's see if it's charging. Should start charge. It's restarting. That sucks. Yeah, this is not working at all. That sucks. Pressing the power button. No, it's not working without that chip. No. It's not working without that chip. The one we remove it. But the laptop is on. That's sick. Okay, so the laptop is on. It is working on the battery, yeah? Let me power off. It is working on the battery because the AC chip doesn't have to speak with the PD controller. But it's not charging. No, it's not charging. I believe the AC chip want to speak with both chips. The AC chip want to speak with the both PD controllers. because otherwise I cannot explain why it's not charging. Not only it's not charging, but it's not working on this. And that's strange, yeah? 1 second. Let me check one more time. So here we have 19. Here we have 12.2. I took out the battery. We have 13.2. 13.2. So why is not charging the battery? No, it's not charging. 12.5. Okay, let's go with the power supply and let's try to charge the battery ourselves. Let's see what is gonna happen. Let's see. So the battery is charging with 500 milliamps. The laptop doesn't care about that. Now the battery is charging with 1.3 amps. Nothing. And if we are powering the laptop, yeah, the laptop it is coming on, but it's coming on the battery. And the CPU is mad hot. Mad hot. Yeah, we do have picture. What about if we unplugging the battery? Yeah, it's shutting down. Pressing the power button, nothing happens. So without the battery, the laptop is not starting. That sucks. Okay, let me see if I have this chip. Okay, on this point we don't have too many options, yeah? So the only option is to order this chip because it's banned. Let me try to find it online. I found it, yeah? Okay, there is no way I will order from this guy. And I will not order from this guy, yeah? Because I have an order and I didn't receive it. So I open a case and the guy didn't respond yet. So not from here and not from here. DD, I don't need DD, I need DA at the end. Okay, not from this guy. DC, no. DC. No, so we have only one option, yeah? To order from this store. That's all what we have. So I'm gonna order, yeah, it's DA, you can see it, that's the chip. So I'm gonna order the chip, which is coming from Petersburg. And hopefully, but you know what, I do remember the seller name, and I don't remember in a good way. Anyway, I will order one, and we're gonna see next time if it will work or not. I mean, at least we know that's the only problem. It is working on the battery. We see in picture, yeah? So see you on the next one. So we are like 3 days later, and I got the chip. TPS, okay? So let's replace this chip quickly, and let's see if the laptop is working. I left the laptop on one side. I didn't put it back. Okay, so this is the old chip, and we have to solder the chip there. Yeah, got it. Okay, let's solder the chip. I mean, hopefully it will work. The solder balls are fine, but I don't think I want that solder balls there. Now let's open the new chip and see if it has solder balls. Probably it has. Okay, so that's the chip. Let's take the chip out. It has solder balls, yes, so I'm not comfortable to solder over that solder balls. So let's take the solder balls out quickly. Brush in. Okay, let's lower the solder temperature. Perfect. Perfect. Now let's come with the new chip. The pin number 1 is there, right? Yeah, it is there. Soldering temperature, let's lower to 390. Ha. Okay, let's see now. We are waiting for the chip to slide. It's not sliding. It's not sliding because the position was perfect. So now is the moment. It will work or not. The thing is, I don't really remember. I mean, wait, I do remember. So the AC chip was shorted. Yeah? No, the 3.3 was missing, yeah. And this chip was getting hot. Yeah, now I remember. Yeah, I remember now. Okay, let's cool the board. And we can test with the meter, yeah? USB meter. Now let's plug the meter. So here is coming on the meter. 19. And here 19. It's working. Now the question is this laptop, it will come on now? What do we need in order to test the laptop? Where is the power button? Where is the power button? Oh, it's here on one side. Okay, the power button is here. Good. Let's try it. Pressing the power button and nothing happened. That's crazy. I mean, I can see the power LED. You can see that it's flashing. Oh, wait, it is coming on. 800 milliamps. It is coming on. The CPU is mad hot. Picture, I want picture. 1.2 amps. Wow, the CPU is mad hot. We have picture. I can't believe. Actually, it's working. Lol. You know what's the problem? You know what? Let me HP. Okay, HP. I forgot it's HP. Just to understand how a laptop is made to fail. Yeah. 1 second. 1 second. So what I will do, I will draw quickly the schematic. Yeah. So you have here the EC chip, right? You have the EC chip. This is the actual schematic of this laptop. Then you have one PD controller, PD. I mean, we are not speaking about the main power rail. We are speaking about the 3.3 LDO, 3.3 volts LDO. So this is one PD controller, and this is the second PD controller. Okay? But those lines, yeah, don't get me wrong, those lines are connected together. And from here, you have the port, yeah, USB-C, USB-C. And here you have USB-C. Now, you understand where is the issue. You understand how absurd is this case. So basically, what we found the EC chip. If I remember, the EC chip was very low resistance or shorted, something like that. Anyway, the 3.3 LDO was missing. When I came with the power supply here, yeah, I came with the power supply with 3.3. I remember this chip was getting mad hot, right? This one. So this one, it was getting mad hot. Good. Now, one more thing about the PD controllers, they are speaking, digital speaking, about with the EC chip, yeah? With a bidirectional communication with the EC chip. So what we did, we removed one chip. Okay, we removed one chip and we did had the 3.3 volts. Yeah, so the 3.3 was there. Now, why the laptop didn't work without this chip? Yeah, with the one with the shorted one. Because the firmware is programmed in a way, if one PD controller is missing, okay, it will not work with only one PD controller. Yeah. Now, just to understand how the absurd is this case, I mean, they could very easily, yeah. Don't get me wrong, very easily. I will delete this line and this line, yeah. They could fit, yeah. Just a diode, that's all. One diode here and one diode here. That's all. That's all what we need, two diodes. So one chip is getting shorted. The voltage, the LDO voltage from the other chip is not going on the other way around to short the 3.3 LDO. So you see, on this case, with two diodes, this laptop could work with only one USB-C port if the firmware, it will allow the communication with only one PD controller. But the firmware, aka the BIOS, is programmed in such a way, if you remove the PD controller and the EC chip cannot speak with that PD controller, which is doing nothing because your cable, yeah, is plugged here. Doesn't matter if the cable is plugged there because that was the case last time. The EC chip wants to speak with both PD controllers. I mean, this is made to fail, is made to punish the customer when one PD controller is failing. I mean, they could easily, you know, just using two diodes, that's all. Using two diodes and redesigning the firmware, they could easily, you know, allow to the customer, even if one PD controller is getting shorter, like what happened here, the laptop could still work using one USB-C. So you understand, on those days, the wheel is missing. The wheel making something durable is missing. No one is looking to make something durable like laptops. Like, okay, let's make this laptop to work for a few years. So even if one PD controller is dying, the customer still can use the other USB port. No. Okay, so I'm gonna stop here. I'm happy I helped this customer. We fixed the laptop. If you have this particular model, you really need other PD controller, otherwise it will not work, which is insane. I never find something like that. I mean, we replace PD controllers, but usually, okay, one PD controller is dead, is still working on the other port, but not HP. So thank you for watching. Like and subscribe if you like the video, like always, and see you on the next one. Bye.